Hello Algebra 2 students, Miss Huss here for your last instructional video. So hang in there with me through this one. Make sure that you have done yesterday's video. You will need that in order to understand what's happening here, as well as some of the factoring stuff from earlier as well. So grab those things first if you need them, then make sure you've either printed out the worksheet attached to today's lesson or that you have a place separate to write and take notes with me as we do this. We're going to get started here with adding and subtracting when you don't have a common denominator. So before we talk about rational fractions that have x in them, let's talk about how to add fractions by finding a common denominator normally. So yesterday you were always starting with a common denominator, today you're not. For example, here I'm trying to add 1/3 plus 2/5. And you're going to notice that the problem here is that those wholes are broken into a different number of parts. And so I am not allowed to add those together. I can't add the parts together until I have the wholes broken into the same size chunks. And so if I'm looking at my denominators, my 3 and my 5, I'm thinking to myself, what could a common denominator be for 3 and 5? And hopefully you guys are all yelling at your screen right now, Miss Huss, it's 15. So we're going to try to get both of those numbers to multiply up to 15. I need to pick a number that both 3 and 5 are able to multiply up to. And so I'm going to think to myself, okay, so right now this denominator, this first one is 3, and I'm trying to get it to 15. So what do I need to multiply by? Well, I need to multiply by 5/5. And so I multiply 5 times 1 on the top, and that's 5, and then that 5 times 3 on the bottom is what gets me to 15. Then you're going to look at your second fraction and say, okay, well, how do I get this 5 to 15? Oh, well, I've got to multiply that by 3. So I multiply by a giant 1, a 3/3, and that 2 times 3 on top is 6, and 5 times 3 on the bottom is 15. Now, those are chunks of the same size pieces. I've got 5/15 and 6/15, and so now if I just combine those together, total I have 11/15. Okay, so we're going to use that idea of trying to get a common denominator here in order to add or subtract fractions that have x in the bottom. And so your next problem down below looks like this. It's 2x over x minus 1. Plus 3 over x plus 5. And just like on the last one here, I had 3 and 5, and I was trying to get those to 15. Here, now I've just got two pieces. I've got an x minus 1 and an x plus 5. So the denominator I'm shooting for is going to have both of those pieces in it. It's going to have the first denominator and the second denominator. And so the denominator I'm shooting for on both of those fractions is going to be x minus 1 times x plus 5. Notice that I just took both pieces and made sure they're both represented in the denominator I'm looking for. So if I look at this first fraction right now, it has the x minus 1, but it's missing a piece of this denominator that I'm shooting for here. It has x minus 1, but it's missing the x plus 5. And so what I'm going to do is multiply by a giant 1 there, and I'm multiplying by x plus 5 over x plus 5. Notice that now on the denominator, I am going to have both pieces that I'm looking for. In the numerator, I have to multiply and distribute that 2x into both pieces. Okay, so I'm multiplying 2x times x and 2x times 5. And that gives me 2x times x is 2x squared, and 2x times 5 is 10x. So that's where I end up. I'm going to do the same thing on the next fraction. If I look at this fraction, if this is the goal that I'm shooting for in my denominator, I already have the x plus 5. What I'm missing is the x minus 1, and so that's what I multiply by on the top and the bottom. And I need to distribute that 3 in to both the x and the minus 1. And so that gives me 3 times x is 3x, and 3 times negative 1 is negative 3. Now, just like once I got here to a common denominator, I was able to just add my numerators. That's what we're going to do here. My final answer, just like I had 15, and then my answer said 15, here I take both of those common denominators, and that's going to be the denominator of my answer. All I got to do is combine like terms on the top. So that 2x squared has nothing to combine with, it just comes down. 10x can combine with 3x, and notice that I'm adding in the middle, and so I combine them by adding, and then there's nothing for negative 3 to combine with, so that just happens right there. Now, I'm curious, is that as simplified as my answer can get, or can I do some factoring to simplify out a giant 1? And so I look at what I have on the top. It's got an x squared. So what I'm going to try to do is look for a greatest common factor first. 2, 13, and 3 don't have a greatest common factor. And so I'm going to try to do a box and a diamond. So off to the side, I'm going to set it up. And you're going to kind of watch that happen. I put 2x squared down on the bottom left. Negative 3 on the top right corner. I know that the 2 that I'm left with have to add to 13x. And then I multiply that 2x squared and that negative 3 to get negative 6x squared on top. If that was too fast, go back and watch the old factoring video, and that'll give you the more detailed description of that if you missed that video. So I'm looking for 2 things that multiply to negative 6 and add to 13, and there's nothing. And so that means since I can't factor the top, I'm done. That's my answer. That's when I add my 2 fractions together, that's what I get. One last piece we have to do is what can't x be? So I'm looking at the 2 things in my denominator. I don't want them to equal 0. So x minus 1 shouldn't equal 0, and x plus 5 also shouldn't equal 0. You're going to solve both of those, and that leaves me with x can't equal 1 and x can't equal negative 5. Okay, so this is my answer with these conditions. All right, let's try that again. In this first problem, you've got a list of steps up at the top that you can follow if you need to. First thing we're going to do is think about what is our common denominator going to be. And here's what you're going to notice. Both of these fractions have x plus 3 in the denominator, but this first one also has an x minus 3. And so I need that x plus 3 represented. I also need that x minus 3 represented. And so this common denominator is what I'm shooting for both fractions. You're going to notice that the first fraction already matches the common denominator I'm shooting for, so I can just bring that 9 minus 3x down. There's nothing I have to do to that. However, the second fraction has the x plus 3, but it's missing something. It's missing the x minus 3, and so I need to multiply by a giant 1 of x minus 3 over x minus 3. And I distribute that 5 into both pieces on top. We're not going to multiply out the bottom. We're just going to write it out as a product. But I multiply 5 to x, and I get 5x. And 5 times negative 3 is negative 15. Now we're going to combine like terms across the top. Again, this is addition. So we're going to add negative 3x and 5x. And that gives me 2x. And we add 9 and negative 15, and that's negative 6. You can see I circled and underlined. And then all over that common denominator of x plus 3 and x minus 3. Now, there's no x squared on the top, so I don't have to worry about a box and a diamond, but I look at 2x and negative 6, and they do have a greatest common factor that I could pull out to the front. That greatest common factor is 2. And so what I'm left with when I take a 2 out of 2x, I have just an x left, and when I take a 2 out of negative 6, I have a minus 3 left. Okay? And then I'm looking at the fraction I'm left with, and I'm asking myself, is there anything that I can make a giant 1 out of to simplify this? And there is. Those x minus 3's can go, and I'm just left with 2 over x plus 3. Okay? So really, the trickiest part is getting that common denominator, and after that, it's all similar to what you already did before. Before we're done with this problem, I need to look at what can't x be, and I need to do it from my common denominator stage. And so I'm looking for x plus 3 couldn't equal 0, and neither could x minus 3. And I solved both of those. And x can't be negative 3 or positive 3. Now I want to let you try this next one, but I'm going to have you do it in stages. And I'm going to walk you through it piece by piece here. So this is kind of like a you try problem, but we're going to do it in pieces, kind of like we would in class if we were all together. So first thing you have to decide is, what is the common denominator going to be? Hopefully you ended up with x plus 4 and x minus 4, because that's what the first one is. The second one has an x plus 4, but it's missing that x minus 4. Okay, so next thing you're going to figure out is, what do you have to multiply that second fraction by in order to have it match that common denominator? It has one piece, but it's missing one piece. What's it missing that you're going to have to multiply by? Okay, and you are going to have to multiply that one by x minus 4 and x minus 4. However, go ahead and write out your 2 fractions. That first one already has the matching denominator, so you just bring that 2x down. Go ahead and fill in the numerator of that second piece. When you distribute that 1 in, what are you left with? Okay, you are left with x minus 4. And now you're going to combine across the top, but be careful, you're combining here with subtraction. So remember from yesterday's video, you need to distribute that negative into both of those to combine. So I'm going to give you a second to do that step. So you did 2x minus x, and that gives you just an x. And then there's nothing, so 0 minus negative 4, and that minus negative turns it into a positive 4. Okay, now you're going to ask yourself, is there anything, any giant 1 that you can make? And if so, do it. And when you simplify that, you can eliminate those x plus 4s, so you're just left with 1 over x minus 4 as your answer. Don't forget to say what x can't be. And x can't be anything that would give you 0 in the denominator, so we don't want x plus 4 or x minus 4 to equal 0. And if you solve both of those, you would get x can't be negative 4 or positive 4. Okay, we're going to do one more together. You're going to try one on your own, and then that is it. So this first problem up here, notice I kind of already wrote it out for you, but both fractions have a 3x plus 1. Okay, this one also has an x minus 5, which means this first fraction is missing an x minus 5. We need to multiply by a giant 1 of x minus 5 over x minus 5 in order to get it to match that common denominator that we're shooting for. And so you're going to distribute an x into both pieces, and that gives me x squared. X times x is x squared, and x times negative 5 is negative 5x. The second fraction already matches the common denominator, and so I can just bring that 2 minus 2x squared down. Now we're going to combine by subtracting into one fraction with the common denominator carried down. And so I'm going to do x squared, and here notice that it's minus a negative 2x squared. That minus negative turns it into a plus 2x squared, and that gives me 3x squareds. And then minus 5x from the first fraction, and minus 2 from subtracting that 2 in the second fraction. Now, I have an x squared, so we're going to try to factor with a box and diamond. So go ahead and set up a box and diamond here to factor that numerator, the 3x squared minus 5x minus 2. And in filling that in, you put 3x squared in the bottom left, negative 2 in the top right, and then you end up with negative 5x on the bottom, negative 6x squared on top, and you can see my writing is getting ahead of me, but hopefully you were able to finish that box and diamond. Negative 6x and x are what multiply to give me negative 6x squared and add to negative 5x. And then I put those in either order in the box, fill in the outsides, and so I can replace that numerator with x minus 2 and 3x plus 1, and then I'm just going to carry that denominator down, x minus 5 and 3x plus 1. Now you're looking for any giant 1s that you can get rid of. Actually, I think I stopped and did the what x can't be first. So before I got rid of any giant 1s, I can't have x minus 5 equals 0 in the denominator or 3x plus 1. So why don't you go ahead and solve both of those to tell me what x can't be. First one should be easy. X can't equal positive 5. Second one, you had to subtract 1 first and then divide by 3. So negative 1/3 or negative 0.33 repeating. And now you can look for a giant 1 and cancel that out. We can get rid of that 3x plus 1 on the top and the bottom, so this thing simplifies to x minus 2 and x minus 5. Okay? You're going to give the next problem a try. Have faith in yourself. You can do this. Take it little piece by piece. Figure out your common denominator first. Multiply whichever fraction you need to get that common denominator to match. And then simplify down as far as you can. You might need to do a factoring on the top, and tell me what x can't be. And then come back and let's check your answer. All right, so this is gonna go quick. This is meant to just show you what the answer should have been. You can pause and stop and look at the work if you need it, but you will get tomorrow to practice, so don't panic. We're not gonna teach you more new stuff tomorrow, but let's go through the answers here. So that common denominator needed an x minus 4 and an x plus 5. Second fraction already had it. First one just needed an x plus 5. So I distributed that 2x in to both the x and the plus 5. And then combine everything into one fraction, this time with addition in the middle. So the only thing I needed to combine was this 10x and this negative 17x. And now from here, that's where you would need to do a box and diamond. So if you didn't make it this far, try it now. Do a box and diamond. If you did make it this far, let's check your box and diamond. So it looks a little something like this. And when you factored, you should have ended up with 2x plus 1 and x minus 4 on the top, kept that x minus 4 and x plus 5 on the bottom. Your x can't equal 4 or negative 5 because that would make zeros, and then you're able to eliminate those x minus 4s with the giant 1. You're left with only 2x plus 1 on the top and only x plus 5 on the bottom, okay? I know that this is a lot. Have faith in yourself. Be resilient. We're almost to the end. You can do this. As always, let any 3 of your teachers, whoever you have, know if you need absolutely anything. We're here for you, okay? Hang in there, guys. We'll see you tomorrow for some practice.